Alright, so the first passage we're dealing with is concerning anaerobic oxidation of methane. Alright, let's take a look at the first question here. Considering the average percent by mass of aragonite at a depth of 10 centimeters shown in figure 3, on average the mass in grams of aragonite present in a 50-gram sample of sediment taken from that depth will be closest to which of the following? Alright, so let's take a look at figure 3. Alright, so at 10 centimeters we have an average percent by mass of 10 for that particular substance, aragonite, the dotted line. So essentially you need to think about what 10% of 50 grams is. Okay, and that's where the 5 grams is going to come from. Alright, in 34, the procedures of studies 1 and 2 differ in which of the following ways? In study 1, samples were. Okay, so let's take a look here. It looks like they had 10 locations and they took 2 vertical samples at each location. Study 1, they're going to examine that for various reactants in the anaerobic oxidation of methane reaction. So here are those 2 reactants that they're looking for. Your methane here, and it looks like a sulfite there. Okay. Study 2, they're going to look at the amounts of these 2 products, calcite and aragonite. So let's go back to the question there. We're looking at how studies 1 and 2 differed. Okay. So let's think about this. In study 1, did samples, were they analyzed for the reactants of anaerobic oxidation of methane? Yes, they were, because here are your reactants in that equation. So study 1 was examined for those. Again, it tells you they were analyzed for. Here's your 2 reactants right there. Okay. Study 2, the samples were not analyzed, so it looks like F is your best answer. Let's take a look at the rest. Study 1, samples were not analyzed for the reactants. That's just not true, because you did analyze for the reactants. Analyzed for the direct products of anaerobic oxidation of methane? No. We looked at we're looking at the reactants. And then not analyzed for the products of anaerobic oxidation of methane? True. Whereas in study 2, samples were analyzed for the products of anaerobic oxidation of methane. This might be a distractor here, because the calcite and aragonite that are mentioned earlier they're not exactly products, because they're not listed in this side of the equation. However, this bicarbonate can combine with calcium to form these 2 compounds. So because these are not the direct products, that rules out J as well. Okay, so F's going to be your best answer there. Alright, and then the next passage here is going to deal with pulling some blocks across a surface. Question 26, based on figure 1, the results of experiment 1 are best modeled by which of the following equations? Looking at figure 1, you're basically dealing with a linear line here. So recall that y equals mx plus b. Take a look at your y-intercept. It's 0. So y equals mx. We have a y value over here, which is basically a force. So N equals, my slope, it looks like for every kilogram, I'm getting 5 newtons of force. 2 kilograms 10, 3 to 15, and so on. So M is my slope, which is 5. And then my X value is kilograms. So basically I have newtons equals 5 times my mass, which is kilograms. So which is going to be my best answer here? Figure 1 doesn't deal with block speed, so I can basically roll out F and G right away. And then we have two options here. The pulling force equals 0.2 times the block mass. No, because 0.2 is not the actual slope value. It's not the relationship between the change in y and the change in x. So J is my best answer there. At each of the times plotted in figure 2, except for 0 seconds, as block mass increase, block speed does what? Okay, so looking at figure 2, I can see that my 2 kilogram block has greater speeds at every second interval, as opposed to 2.5 kilograms and 3 kilograms. For example, at 1 second, I'm at 10 meters per second for a 2 kilogram block. This is going to be somewhere around 7 meters per second for the 2.5 kilogram block, and the 3 kilogram block at 1 second is going to have a speed of 5 meters per second. So you can see that it looks like there's an indirect or an inverse relationship between those variables. So as the block mass is increasing, my block speed is decreasing only. So B is your best answer. Based on figure 1, an applied force of 30 newtons would most likely have been required to maintain the constant speed of a block having a mass of what? Okay, so going back to figure 1, we already looked at the relationship between y and x. For every kilogram of mass, we're getting a 5 Newton force value. So it's a 5-to-1 ratio of y per x. 10 per 2, 15 per 3. Okay, or you could say 15 divided by 5 is 3, 20 divided by 5 is 4, 25 divided by 5 is 5. So if I'm predicting out here, this is going to be 25 with 5. And so for a 30 Newton force, I'm going to have a mass of 6. That gives me that 5-to-1 ratio. 30 newtons per 6 kilograms equals that 5 newtons per 1 kilogram ratio. So it's got to be the 6. Okay. And then we have a passage here dealing with bacteria breaking down sugars by fermentation. All right. The first question that we're concerned about. Suppose in experiment 2 both species B and C are added to a large test tube containing sucrose and to a large test tube containing lactose. Which of the following will most likely depict the results? Okay, so we're adding B and C. So if I look at table 1, I can see that B with sucrose broth is negative for both the production of acid as well as carbon dioxide. It is, however, positive for both acid and CO2 when given a different medium, lactose. Species C is positive for acid and positive for CO2 when given sucrose, but it's negative for both those same two with the lactose as my medium or my broth. Okay, so I can pretty much predict if I put them together, they're going to give me positive results across the board. Okay, if they're together in sucrose, well then C is going to give me positive results for acid and CO2. If they're together in lactose, then B is going to contribute acid and CO2. So based on all information, if I have both of those species in both of those media, I should get positive results across the board there for both those media. And then suppose a scientist isolates a bacterial species that is one of the 4 used in experiment 1. She's going to add the species to sucrose broth and observes that neither acid nor CO2 is produced. So I'm negative for acid and negative for CO2. However, I'm going to add the species to lactose, and the broth is acidic and CO2 are produced. So based on the results of experiment 1, what's the species most likely to be? Okay, so I'm basically negative for acid and CO2 if given sucrose, but if I'm given lactose, I'm positive for both. So going back to table 1, which one is, we need a negative and a negative for sucrose, so that rules out C and D, but then I need to be positive for acid and CO2. So the only one that is negative for acid and CO2 in sucrose, but then positive for acid and CO2 in lactose is going to be B. Okay, so we're dealing with G as our best answer there, species B. And then moving to 32, which of the following figures best illustrates the results of experiment 1 for species D in sucrose broth? Okay, so remember, species D in sucrose broth, I get positive for acid and negative for CO2. The reading tells you that if we get acid, the solution must be yellow. So again, let's take a look at our choices here on 32. So right away I know that red, it cannot be, so it's between H and G. And recall that sucrose for species D, sucrose, it's positive acid, which is I already ruled the reds out. I know it's got to be yellow, but there is no CO2 produced, so there cannot be a gas bubble. So going back to my data here, they got a gas bubble being produced here, so that rules him out, and that makes G my best answer.